Hello students, welcome to Pharma E-Class. I am Dr. Tahir Nizami, Associate Professor at Smriti College of Pharmaceutical Education, Indore. In series of our lecture of infrared spectroscopy, now today we will discuss about the instrumentation part of infrared spectroscopy. Just like we had discussed about UV spectrophotometer and flame photometer, now IR spectroscopy instrumentation is also almost similar. Every type of spectroscopy technique has a radiation source. Likewise, IR spectroscopy is also having one radiation source. Now, this radiation source is capable to emit the radiations of IR range. Now, this other than radiation source, the important part of instrumentation are two mirrors which reflect the radiation which emit from the source into the reference cells and the reference cell and the sample cell. Now two sample holder, one sample holder is for reference, another sample holder is for our sample. Again mirrors which diverge the radiation which come out from the reference cell and sample cell into the monochromator, and a chopper. This is a chopper. Now the function of chopper is to transfer the light which is coming from the mirror of reference cell and sample cell into monochromator. Now from chopper the radiation fall into the monochromator, and as name suggests, monochromator means changing the light of particular wavelength of desired wavelength. This monochromator allow only light of IR radiation to get into the detector. Which amount of light which is sent from the sample is entered into monochromator, and only the IR part of IR radiation is allowed to fall on the detector. So this is monochromator, and basically our monochromator is made up of prism, or it is made up of some gratings that we will discuss after some time. After monochromator, the light will go on the detectors. Now the most important part of the IR spectrophotometer instrumentation is detector. Now the detector is a part which is responsible for detect the amount of light which is coming from the sample or reference cell. Now as we have understand in our previous videos that in IR spectroscopy we are interested only in the amount of light which is transmitted by the sample but not absorbed by the sample. So here the detectors like we have bolometer detector, we have thermocouple detector or thermistor detector are applied in such a way that they are capable of evaluating the amount of light which is transmitted by the sample, that is IR radiation which is transmitted by the sample or the reference substance. Now after detector there is amplifier. The signal in the form of current is amplified, and the amplifier then we have recorder, and in recorder we will get the peaks which are inverted peaks. As I have discussed, their peaks are inverted in IR radiation, stretching and bending vibration peaks, because here we are not interested in knowing the amount of light which is absorbed by the sample, but we are interested in the knowing the amount of light which is transmitted by the sample. So basically in IR spectroscopy instrumentation, the major part is source, mirrors, then reference cell holder, sample cell holder, chopper, again mirrors, monochromator, detector, amplifier and recorder. So light which come from source first get into the mirror, that mirror convert this light, divert this light into reference or sample cell, reference cell or sample cells. The light then passes to go to mirror, then this mirror divert this light to chopper, chopper divert this light to monochromator, from monochromator only X-ray, only IR radiation pass to detectors, detector detect the amount of light which is transmitted by the sample, and it go to amplifier, the signal in the form of current, and to an amplifier. Now the current is very slow, very less in amount, so amplify the amount or the current in a range of detectable range, and recorder will record the signal. So this is about the instrumentation part. Now let us discuss about the radiation source. Just like every spectroscopy have one radiation source, IR spectroscopy is also having one unique radiation source. Now the radiation source may be nurse glower or globular cells. The very common radiation source is in IR spectroscopy is Nernst blower. The reason behind its popularity is it produces wide range of IR radiation which is utilized in excitation or vibrating the molecules. Now, Nernst blower is basically made up of oxides of certain metals like zirconium, deuterium and erbium. Now these oxides of zirconium, deuterium and erbium are taken in the ratio of 97 part of zirconium oxide, that is ZrO2, 7 part of deuterium oxide, that is Y2O3, and 3 part of erbium oxide, that is Er2O3. So in Nernst blower, oxides of zirconium, deuterium, erbium are taken in the ratio of 97:7:3 for preparing Nernst blower. This Nernst blower basically a type of hollow rod which is made up of these oxides, and these hollow rod are hollow from inside with having diameter of 2 to 2 mm, and it is having length about 30 millimeter. So these hollow rod are made up of oxide of zirconium, deuterium and erbium. It is hollow inside and it is having diameter of 2 mm and length of around 30 mm. Now this hollow Nernst blower is non-conducting in nature because it do not conduct heat or electricity. So to make and it is non-conducting at room temperature. So to make it conducting and to emit the heat and light energy, we have to supply it some energy in the form of heat, and that is why this type of hollow rods or Nernst blower has to be supplied with some amount of heat to get glow. Now we supply heat around 1000 Celsius degree temperature, and then these start glowing and start emitting IR radiation of wide range, and this IR radiation are utilized by the sample for exciting their molecules for producing vibration or rotation. So next type of radiation source is Glober cells. Glober cells is basically a rod which is made up of sintered silicon carbide, and this has a diameter of 4 mm and length of 50 mm. Now just like in Nernst blower, Glober cells also require heating, and heating Nernst blower produces light of IR radiations. Now as far as sample is concerned, in my next video I will discuss about the sampling techniques in IR spectroscopy. The samples can be in the form of solid, liquid, gaseous or in the form of solution form. Now let us come to monochromator. So the source emit the light, this type of source, Nernst blower or Glober source, emit the light of IR radiation that enter into reference cells or sample cells. This slices this light from reference cells and sample cell via mirror and chopper enter into monochromator. Now let us discuss monochromator in detail. As name suggests, monochromator, that is chroma matlab light, mono matlab single wavelength. So the role of monochromator is to convert or allow the light of only IR wavelength to pass through it. So here the sample, from the sample and reference cell, light of a different wavelength is coming, but monochromator only allow the light of IR radiation to go through this, because monochromator contains some slits, and monochromator are made up of prisms and gratings. So prisms are made up of glasses made up of alkali metal halides like sodium chloride, potassium bromide, lithium fluoride. So this anyone can ask you question about what are prism made up of in IR spectroscopy, monochromator prism are made up of. So in IR spectroscopy, monochromators are made up of prisms. Prisms are made up of alkali metal halides like NaCl, KBr and lithium fluoride. And there may be gratings. Gratings are nothing but simple prisms which are put on or in the sequence at the base, and this prism arrangement is known as gratings. Now next come detectors. Detectors is a very important part of IR spectroscopy. The important type of detectors are bolometer, thermocouple and thermistor. Bolometer are type of detector which contain a thin metal plate which is conducting metal plate, and we heat due to heat from this IR radiation, the temperature of this increases. As the resistance increases, there will be a change in current, and that change in current is measured by our ammeter or galvanometer, and that is amplified and recorded. Now next is thermocouple. Thermocouple is having two wires, and these two wires have two junctions. One is hot junction and another is cold junction. A part is known as hot junction because here air radiation fall. This air radiation fall into this A junction. That is why it is known as hot junction. This cold junction, the difference in temperature produces difference in current, and which produces potential difference, and that potential difference is measured by our galvanometer. Now next type of detector is thermistor. Thermistor detectors are just like a bolometer. They are made up of fused metal oxides. Unlike bolometer, which is made up of thin metal conductors, they are made up of fused metal oxides. Now when the IR radiation fall on these fused metal oxides, and these metal oxides start producing current, and the increase in temperature produces increase in resistance, and the increase in resistance produces current, and that current is amplified by amplifier, and the recorders record the signals. So this is about the instrumentation part. The important part is the radiation source, the samples, the monochromator, detectors, amplifier and recorder, and this is how the IR spectroscopy instrument works. Hope you have understood, and in next lecture we will discuss about sampling technique in IR spectroscopy. Thank you.